Every single time you browse the web, there's this invisible war being fought right inside your browser. It's a constant battle to keep your information safe. So today, we're going to pull back the curtain on the fundamental security rules that protect you and show you how clever attackers try to turn those very same rules against you. Okay, let's get into it. I mean, really think about it for a second. You've probably got your email open in one tab, maybe your bank account in another, and you're reading some article in a third. What's really stopping that news site from just reaching over, digitally speaking, and peeking at your bank balance? Well, the answer is way more interesting than you might think. You see, your browser is built on this foundation of security principles, all designed to prevent total chaos on the web. But here's the kicker. The real genius behind so many web attacks, they don't break the rules. They actually exploit them. They trick your browser into doing exactly what it's supposed to do, just for a totally malicious reason. So let's start with the absolute cornerstone of web security. It's called the same origin policy. Honestly, the easiest way to picture it is to think of the web as a giant apartment building. Every website you visit, it lives in its own locked apartment. This policy is basically the rule that says the tenant in apartment A can't just stroll into apartment B and start going through their stuff. The most important part of this whole thing is that this rule is enforced by your browser. It's like your own personal security guard. It's the thing that says code from, say, evil.com is absolutely forbidden from reading or messing with the data on mybank.com. This is the fundamental rule that keeps all your browsing sessions separate and safe. Now, to enforce this rule, the browser needs a really strict definition of what a website's address is. In the lingo, that's called its origin. And an origin is made of 3 distinct parts that all have to match perfectly. The first part, that's the protocol. HTTP, or hopefully the more secure HTTPS. The second part is the domain name. This is the bit you'd recognize right away, the specific location of that apartment in our building, something like portal.mysite.org. And the final piece of the puzzle is the port number. Now, you usually don't even see this part because browsers just use defaults, port 80 for HTTP and 443 for HTTPS. But if a site uses a different one, that port number becomes part of its unique address, its origin. And let me tell you, the browser is incredibly strict about this. Just look at these examples. All 3 parts, protocol, domain, and port, have to match exactly. If you just change from HTTP to HTTPS, nope, different origin. Changes subdomain from portal.mysite.org to just mysite.org, sorry, different origin. And change that port from the default to 8000, you guessed it, different origin. There is absolutely no wiggle room. Okay, so if every website is totally isolated, that brings up a question, right? How does a site like Amazon remember who you are when you click from one page to the next? The answer is cookies. The best way to think of a cookie is like a concert wristband. The person at the gate gives it to you when you come in, and for the rest of the night, every single staff member knows you're allowed to be there. Cookies are just like that. They let a website remember that you're logged in. But this whole memory thing, it creates 2 major security problems we have to solve. First, you can't have evil.com creating a fake wristband for mybank.com. And second, your browser has to be smart enough not to go showing its mybank.com wristband to every other website it talks to. And to manage all that, your browser follows another strict set of rules called the cookie policy. It really just governs 2 simple but absolutely critical actions: when to accept and store a cookie a website gives you, and, just as important, when to send that cookie back. And this is where our story gets a villain. Because what if an attacker could trick your helpful, rule-following browser into using your totally valid cookies for a malicious purpose? This is the whole idea behind one of the web's classic and most famous attacks, cross-site request forgery. Okay, here's the heart of the attack. Imagine you're at a food truck festival, and you have a prepaid wristband for your favorite taco truck. A scammer comes up, points to the taco truck and shouts, "Hey, they're giving away free churros over there." You, of course, yell back, "I'll take one." The taco truck sees your valid wristband, they hear an order, so they charge you for a churro, but it wasn't you who wanted it, it was the scammer who tricked you into placing the order. CSRF is the digital version of that exact scam. So here's how the heist unfolds, step by step. First, you log into your bank, and your browser gets that session cookie, your wristband.
Then, an attacker tricks you into visiting their malicious website. Now, hidden on this site is some code that tells your browser to send a request to your bank, like, say, a request to transfer money. Your browser, just trying to do its job, sees a request going to your bank and automatically attaches your banking cookie. The bank server gets the request, sees a valid cookie, and thinks, hey, looks legit to me, and it processes the transfer, never ever knowing the request was a forgery from another site.
And what's wild is that this attack can be deceptively simple. An attacker could post what just looks like a broken image on some forum you visit. When your browser gets to that page, it tries to load the image from that source URL. But look at the URL. It's actually a command to your bank. And even though no image is ever going to load, the request is still sent. And your browser, well, it helpfully attaches your banking cookie. Just like that, money's gone. And oh, it gets worse. This isn't just for simple actions. Attackers can build completely invisible forms on their webpage. The second you land on the page, a little bit of JavaScript can automatically fill out and submit that form in the background, forging a way more complex request, like, say, changing the email address on your account, all without you seeing a single thing.
Okay, so this all sounds pretty scary, I get it. But thankfully, the good guys, developers, and browser makers have come up with some really clever ways to fight back. We now have two main lines of defense against these forged requests.
These defenses are called CSRF tokens and same-site cookies. You can think of a CSRF token as adding a secret password to every single request that the attacker just can't guess. Same-site cookies, on the other hand, are a newer defense that works right at the browser level, basically telling it to be way more careful about when it sends cookies out. All right, let's talk about the first one, CSRF tokens. When you log into a site, the server doesn't just give you a cookie anymore, it also gives you a second, unique, and totally secret value called a CSRF token. The best analogy for this is a secret handshake. The server tells your browser, look, for this whole session, every time you want to do something important, you have to prove it's really you by giving me this secret handshake. And here's why that works so well. The server actually embeds this secret token right into the web page, maybe as a hidden field in a form. So when you legitimately submit the form, that secret token is sent along with your request. The server then checks for two things, your cookie and the secret token. An attacker can forge the request from their evil site, but since they can't see the web page your bank sent you, they have no idea what the secret handshake is. So the request arrives without it, and the server just rejects it.
But there's an even more modern and, frankly, more powerful defense called the same-site cookie attribute. This is a direct instruction that the server gives to your browser when it first sets the cookie. It's like the bank is telling your browser, hey, listen up, this is a really important cookie. As a new rule, I want you to never, ever send it to me if the request was started by some other website. So with this new rule in place, when the attacker's site at evil.com tries to make your browser send that hidden request to bank.com, your browser itself steps in. It sees the request didn't come from bank.com, it checks the cookie's same-site rule, and it just says, nope, sorry, I'm not allowed to attach this cookie. The request goes to the bank without your session cookie, the bank has no idea who it's from, and the attack is completely shut down before it even leaves your computer. And all of this brings us to one last really important question. If we have these amazing defenses like CSRF tokens and same-site cookies, why is cross-site request forgery still a problem? Well, the answer really lies in just how complex the web is. Not all websites implement these defenses correctly, tons of older systems might not even support them, and attackers, well, they're always finding new, clever ways to exploit the rules. That invisible war in your browser, it's still going on, and the line between a helpful feature and a dangerous security hole is constantly being redrawn.